For many decades, physicists have theorized that the universe is filled with an exotic substance known as dark matter. Its origins and composition remain among the most elusive mysteries of modern cosmology. When we consider this puzzle, the idea that stars, galaxies, and clusters move in ways that cannot be fully explained by the matter we can see, two broad possibilities emerge. One is that there is more stuff out there than meets the eye, unseen matter that does not interact with light, referred to as dark matter. Another possibility is that our understanding of gravity itself may be incomplete. Perhaps we need a deeper theory of gravity to account for these observed motions. When most people think of dark stuff, they might imagine familiar objects like dark planets, burned-out stars, or black holes lurking in the shadows. But the issue is more subtle. We may be dealing not with ordinary objects, but with entirely new kinds of particles, fundamental ingredients of nature that do not emit, absorb, or reflect light, rendering them invisible to telescopes that rely on electromagnetic radiation. If dark matter cannot be seen, how can we be so confident it exists? Scientists deduce its presence from its gravitational effects on visible matter. For instance, stars in galaxies, as well as galaxies in clusters, move as if there were far more mass present than we can account for, using only the matter we detect through light. This leads to the conclusion that something else, something dark, is influencing their motions. An apt analogy is observing a cityscape at night from a distance. We see scattered points of light, street lamps, car headlights, building windows, but we do not see the underlying structures that support these lights. Yet we know buildings and bridges must be there. If not, the lights would simply fall to the ground. Similarly, in the cosmos, we see luminous objects, stars, nebulae, galaxies, but their arrangement and movement suggest an underlying structure we cannot directly see. That invisible scaffolding is what we call dark matter. The concept of dark matter was first introduced in the 1930s by the Swiss-American astronomer Fritz Zwicky. By studying the Coma cluster of galaxies, Zwicky found that the mass of the visible matter was insufficient to keep the galaxies bound together at their observed speeds. This indicated the presence of unseen mass. Decades later, Vera Rubin cemented the case by analyzing the rotation of galaxies. She found that stars at the edges of galaxies moved too quickly to be held in place by the visible matter alone. Like water droplets flung from a rapidly spinning wheel, these stars should have been hurled away, unless an additional unseen mass was providing the necessary gravitational pull. Over the years, astronomers have gathered extensive evidence that galaxies and clusters contain about 4 to 5 times more dark matter than ordinary matter. This suggests that the familiar particles, protons, neutrons, and electrons that make up you, me, and the Earth, constitute only a small fraction of the total mass-energy content of the universe. The rest appears to be made up of dark matter and an even more mysterious substance known as dark energy. What could dark matter be made of? It is not predicted by the standard model of particle physics, the best current theory describing fundamental particles. Some propose that dark matter might be composed of normal but non-luminous objects, cold gas clouds, black holes, or entire dark galaxies made of faint stars. Others suspect that dark matter is made of yet undiscovered particles. Recently, the idea that primordial black holes formed shortly after the Big Bang might account for all of the dark matter has gained some traction. In this scenario, tiny black holes created in the early universe-seeded galaxy formation, and later grew into the supermassive black holes we find in galaxy centers today. For nearly a century, evidence has mounted that something invisible provides the gravitational glue holding cosmic structures together. Yet, after decades of searching for dark matter particles, both in deep underground laboratories and particle accelerators, the mystery remains unsolved. This has led a small but vocal group of physicists to question whether dark matter truly exists. Could it be that gravity itself needs rethinking? In recent years, some theorists have proposed new frameworks in which gravity emerges from more fundamental principles, rather than being a fundamental force itself. Eric Verlinde, a theoretical physicist and string theorist at the University of Amsterdam, has argued that gravity might be an emergent phenomenon arising from the behavior of underlying quantum information. According to this line of thought, what we interpret as dark matter effects might be explained by a modification of gravity rather than by unseen particles. Many physicists and astronomers, however, remain skeptical of these alternative explanations and continue to favor the dark matter hypothesis. They point out the substantial indirect evidence supporting the presence of dark matter. Yet, the dark matter camp also faces questions. Recent findings about the relationship between galaxy rotation speeds and visible matter content challenge the standard narrative and hint that something more subtle might be at play. In the end, whether dark matter turns out to be a new type of particle, a population of primordial black holes, or a symptom of an incomplete theory of gravity, we can be sure that scientists will continue to probe this mystery. As observational techniques improve and theoretical frameworks mature, we may one day look back on this era of cosmic puzzles and marvel at the depth of our ignorance and the elegance of the solutions we eventually uncover. Thank you for watching. If you enjoyed this exploration of one of astronomy's greatest mysteries, please consider subscribing and turning on notifications. Don't miss future videos as we continue to delve into the secrets of the universe.